In this video, I'd like to talk about solving exponential equations with exponent properties. So you can see this example down below where we have to solve the exponential equation for the variable x. And the key thing to notice is that our variable, notice, is in the exponent here. So the question becomes, how do we get x outside of the exponent? And the general strategy with pretty much all of these problems is the same. We want to rewrite each of these exponential expressions where the base, 5 in this case and 25 over here, we want to make these bases equal to each other. So to do that, we want to recognize that 5 and 25 are both powers of the same number. So 5 is really just 5 to the first. You can think of it that way. And 25 we can rewrite as 5 squared. And we're going to make a substitution for 25. We'll replace it with 5 squared. And then we'll use exponent properties to simplify. And once you have the two bases equal to each other, basically we'll have 5 to some power is equal to 5 to some other power. Then for this to be true, A and B must be equal to each other. So once the bases are equal, then we'll set the exponents equal to each other and we can solve for x. So the first step here is to replace 25 with 5 squared. So let's just rewrite the left-hand side. We have 5 to the 2x plus 7 is equal to 5 squared to the 1/3. And just as a general reminder, it's a good habit when you're substituting to substitute inside parentheses. That way, if you do have negative numbers, you can avoid a lot of the common mistakes. So we have this 5 squared and we're going to raise it to the 1/3 power. Now, the general rule with raising an exponent to an exponent, let's look at an example here. We have 2 squared, let's say, to the 3rd power. And the general rule is that when you have an exponent to an exponent, we're going to multiply those exponents together. So this will be equal to 2 to the 6th power. And to understand that, at least with whole numbers, you can use basic understanding of exponents to make sense of this. For instance, 2 squared really just means 2 multiplied by itself twice, and we're going to cube that. We're going to raise that to the 3rd power. So now we're taking this expression 2 times 2 and we're going to multiply it 3 times. So that's 2 times 2 times 2 times 2 and times 2 times 2 again. And you can see there are 6 of these 2's multiplied together. So we're going to apply the same idea here. And granted, it is a fraction rather than a whole number, but this property still applies even for rational expressions, or rational exponents, I should say. So we're going to take 2 and multiply it by a third. So 2 multiplied by 1/3, we can put 2 over 1 and then just multiply these fractions straight across. And we get 2/3. So let's just rewrite our equation now. We have 5 to the 2x plus 7, the left-hand side doesn't change, is equal to 5 to the 2/3 power. And like I mentioned above, once you get the bases equal to each other, the only way that this equation is true is if the exponents are themselves equal to each other. So we're going to set this 2x plus 7 equal to 2/3. So let's just make a little bit of room here, and we can work up here. We have that 2x plus 7 is equal to 2/3. And let's just get rid of the fraction. We will multiply every term by 3, and that'll cancel this out. So you get 6x plus 21 is equal to 2. And let's subtract 21 on each side. So you get 6x is negative 19. And lastly, divide everything by 6, and you get minus 19 over 6. So this should be our final answer, but we want to know for certain. And this is an equation. So with equations, you can always check your work by plugging what you think is the answer back in anywhere you see the variable x. So let's do that. Let's check our work up here. We're going to plug in x is minus 19 over 6 into the equation. So you get 5 to the 2 times minus 19 over 6 plus 7, and we're hoping this is equal to 25 to the 1/3 power. Let's just make a little bit more room and we can keep working. And if you want to use a graphing calculator, there are faster ways to check this, but you should also know how to check it by hand, just so that you understand what the graphing calculator is doing. So we need to simplify this expression up here. So let me just rewrite it. We're just going to work on the left-hand side. And at the end, hopefully this will be 25 to the 1/3. So we have 5 to the 2 times minus 19 over 6. So 2 over 6 we can simplify to 1 over 3. So this is really minus 19 over 3. And we're going to add 7 to that, but let's give it a common denominator so that we can add the fractions. So 7 can be rewritten as 21 over 3. So let's simplify. This will now be 5 to the minus 2, or excuse me, positive 2, since minus 19 plus 21 is 2. And we still have that denominator of 3. And let's use exponent properties to make sense of this. You can either do it from the right-hand side and rewrite 25 as 5 squared and then distribute it so that you really get 5 to the 2/3 like we have. Or let's look at it a different way. 5 to the 2/3 power is really just 5 squared raised to the 1/3 power. And we know 5 squared is 25. So we do get back our 25 to the 1/3 power, which is exactly what we expected. And so since we checked our work and it made sense, now we can feel completely confident that this is in fact the right answer.